Guys, let us continue with today's topic. Before going to the topic, let me recollect what we saw in the last class. We have started seeing about straight line sequencing, and straight line sequencing is nothing but executing an instruction by undergoing fetching and execution phase. Okay, and it will be done in an increasing order. So usually with the help of the PCs, as in the diagram we can see, with the help of the PCs program counter, you are going to fetch an instruction because it is going to hold the address of the first instruction to be executed. Then we go for instruction register. This instruction register will be having that particular instruction, which is going to decode to identify what type of operation the instruction want to do. Then with the help of the processor, it is going to execute. Okay, and finally the result will be stored in the data register. This is what happened during straight line sequencing. And as I told you, instruction will undergo two phases. One is a fetching and execution phase. So today your topic is regarding this diagram. As you can see in this diagram very clearly, memory is divided into fixed size blocks, and each block is holding some information. It can be in terms of an instruction or it can be in terms of a data. So this diagram possesses both the instruction and the data, and data for the program is present in the variable A, B and C. That is clearly notified here in this diagram, and your instruction is present in the top ith location, I plus 4th location and I plus 8th location. As I have told you, PC will be holding the first instruction to be executed, and the next instruction will be present at the location plus 4, I plus 4. That's why add B, 0 is present at the location, address location I plus 4, whereas move A, R0, first line, is present at the location I. So here the program is meant for adding the operand A and B and storing the result in C. So the PC has to, the computer or the processor has to fetch the data from the location A as well as B. Then it has to perform an add operation. So first instruction is, I am instructing the processor to move the content which is present in the location A to R0. Then the second line, I want to perform an add operation. During the add operation, the content which is present in the location B is added with the content which is available in R0. Register R0 is containing the content of A. So which means I am going to add the content of A with B. And finally, the result is going to be stored in C. So in I plus 8th location, address location I plus 8, I am moving the value which is present in the result of A and B, which is in R0, is moved to C. So that result will be present in C. So this is how the entire operation will be taking place. So you have an instruction and the data inside the memory. So the processor will fetch, decode, identify what type of operation it has to do. After completing the operation, again it will store the result in the memory itself. Suppose if you want that data to be displayed to the outside screen through an output devices, we go for an output device. Otherwise, the result will be stored inside the memory itself. That is what we can come to understand based upon this diagram. Okay. Let me go to the next operation, branching. Branching is nothing but similar to executing, but we have another type of instruction called as branch type. So we are going to load a new value into the program counter. Okay, so here the processor is going to fetch and execute the instruction from a new address. That address is said to be a branch target address. So here it has to satisfy the condition in order to move to the target address. So that type of branching is called as a conditional branching. We are going to check for a condition. The condition is going to be satisfied. You are going to move to that particular target address, and from there you are going to execute. That is said to be branching. So here in this example, the branch is greater than 0. If the condition is true, then you are going to execute. That is what this statement implies. Okay. Then these conditions can be set using 4 flags. We have commonly used 4 flags. N indicate negative. So this flag will be set if the result of the instruction is set to be a negative one, or if the result is set to be a positive, then the flag set will be 0. Okay. And Z indicates 0. If the result is going to be 0, this flag is set to 1, otherwise the flag is set to 0. and if there is any overflow condition occur, then we make use of the flag called as a B. Capital B indicate it is an overflow, which will be set to 1 if an overflow condition occur, otherwise it will be set to 0. Okay, then we have carry flag. Carry, if we are going to perform any addition or subtraction, any operation, and if it carries the result is going to carry an extra bit, then we go for a carry C. Okay, it will be set to 1 if the result for the operation have a carry result, or it will be set to 0. So these are the 4 individual commonly used flag used inside an instruction. Okay, let me go to the quiz. So during a instruction fetch, what it will end with, whether it is going to place the data from the address in MAR to MDR, or the data into an MAR, or option C, completing the execution of the data and placing in the storage address, or during the end of the instruction fetch, it is going to decode the data in MDR and place it in the IR. Yes, answer is C. D, as we have seen in the diagram. PC will be holding the instruction to be executed, which will be fetched and decoded, and it will be placed in the IR. So at the end of the instruction fetch phase, we are going to decode the data in MDR and we are going to place it in the IR. Okay, so the answer for this quiz is D. Thank you guys. Kindly refer to the PPT and complete the portion.